All right, in this video we're going to talk about the difference quotient, which is something that is used in calculus when you start talking about what we call the derivative of a function, and we start trying to talk about the slope of a curve at a point, which if you're not in a calculus class, eventually you may take one of those classes where you'll see this type of thing. But the difference quotient is an algebraic thing that you use in calculus to do those things, to calculate the slope of a curve or to calculate the derivative of a function. So it's an important thing to be able to do algebraically in order to to use that in calculus. Right? So this is what the difference quotient is. Right? This is the formula for the difference quotient. It's f of a plus h minus f of a all over h. All right, so that's the difference quotient. It's one of those formulas that, like I said, when you get to calculus, you'll have to memorize that formula. For now, depending on what class you're in, you may or may not have to memorize that formula. But that's what we call the difference quotient. And I'm just going to explain here first where it comes from, and then I'll do an example or two where we actually calculate the difference quotient for some function. All right, so where the difference quotient comes from is actually from the average rate of change of a function. So if you haven't watched the videos that I did on average rate of change, you might want to check those out just so you know what I'm talking about here. But average rate of change of a function basically is the slope of the line that connects 2 points on the graph of a function. Right? So in this case, I'm taking two x values, x equals a, and then x equals a plus h. Right? Where that h represents like some small number. So it's like, for example, from x equals 3 to x equals 3.02, right? Or from like x equals 5 to x equals 5.001, right? So generally we use a difference quotient for 2 points that are really close together, right? And that h just represents, the a plus h means we're pretty close to that point a, and we're just moving a little bit, that little h number we're adding to a to just move a little bit further down the graph to calculate our difference quotient. Now, in the picture here, I put them more spread out, just so that it's more clear what's going on. You can see the picture more clearly rather than having everything like bunched and scrunched together. So from x equals a to x equals a plus h, I want to calculate the average rate of change of the function, or the slope of this, this darker purple line here that connects those 2 points on the graph. I want to find the slope of that line. Right? Well, if you recall, the slope is the difference in the y values divided by the difference in the x values. Well, my y values here, my y2 is f of a plus h, right? When I plug in whatever this a plus h is, whatever x value that is, when I plug that into the function, I get my output is the y coordinate of that point, which is f of a plus h. All right, so f of a plus h, this point up here has the coordinates a plus h comma f of a plus h. Right? Whatever this x value is, then I plug it into the function, and that gives me the y coordinate of that point. So that's my first, or that's like my y2 value, right? This would be like my x2, y2 if I'm using the slope formula. And this point down here, my x coordinate is a, and when I plug that into the function, I get the y value, which is f of a. So that's like my x1 and my y1. All right, so again, I hope this makes sense using letters here instead of numbers, but think about it in terms of a number. If this was a 3, and I plugged x equals 3 into my function, whatever f of 3 is, whatever number that comes out to, that's the y coordinate of this point on the graph. So my point would be 3 comma f of 3. Right? Well, I don't have a 3 here, I have an a, so it's a comma f of a. This one's a plus h, so the point is a plus h comma f of a plus h. Right? I plug those x coordinates into the function to get those y coordinates on the graph. All right, so those are my points, my x2, my x1, y1, and my x2, y2. And like I said, now we want to calculate the slope of the line that connects those 2 points. Well, if you recall the slope formula, it's y2 minus y1 over x2 minus x1. All right, well, y2, that's f of a plus h. Right, minus y1, that's f of a. Right, and that's what this over here says, like the length of that vertical side here is f of a plus h minus f of a. It's the difference in the y values, or the rise in my function from this point to that point. Right, that gives me my rise. So f of a plus h minus f of a over, and then I have to do the difference in my x values. Well, my x2 is a plus h minus my x1, which is a. Right, and if you notice what happens there, that a plus h minus a, the positive a and the minus a cancel out, so I just have an h in my denominator, and that's what this is saying up here. Right, the x1 minus x2, that's my horizontal distance, or my run between one point and the other. Remember, the slope is the rise, the difference in the y values, over the run, the difference in the x values. And it shows up here a plus h minus a, which just equals h. All right? So what I get is f of a plus h minus f of a all over h. That's my difference quotient, right? That's the formula for the difference quotient. Just wanted to show you where it comes from, because if you understand where that formula comes from, if you ever forget the formula, you can kind of draw your own little picture here and say, okay, it's a and a plus h, and let me plug those in and simplify it. Oh, and I get f of a plus h minus f of a over h. That's my difference quotient, right? Like I said, when you get to calculus, you'll definitely have to memorize that formula. Until then, maybe not, depending on what class you're in and what your teacher expects from you. But that's where the difference quotient comes from. It's taking the average rate of change of a function, or the slope of 2 points, or the slope of the line between 2 points on a function, and just instead of using concrete numbers, it's just making it all abstract, right? Just instead of plugging in x equals 3 and x equals 5, let me plug in x equals a and x equals a plus h. But really, that's all you're doing is calculating the slope between those 2 points. That's what the difference quotient is. All right, so I'm going to pause the recording here and erase this big picture, and then I'll put up an example where I'll give us a function, and then we'll actually calculate the difference quotient for that function. All right, so we've got a function up here, f of x equals 2x squared minus x, and I'm asked to calculate the difference quotient for that function. All right, so the difference quotient has a couple parts to it, right? It has the f of a plus h minus the f of a, and then all of that stuff over h. So what I'm going to do, rather than try to put all that stuff together at once, I'm just going to take it one little piece at a time. The first thing I'm going to calculate here is f of a plus h, and this is usually the part that gives people the most trouble as far as how to put that together, just like the algebraic steps you have to do to figure that out. All right, so f of a plus h. I go to my function. Right, first off, before I even do f of a plus h, what if I asked you to do f of 1? Right, what would you do if you had to calculate f of 1? Let me actually put this down here so we can look at it when we do f of a plus h. Right, so f of 1, well, whatever's in that parentheses, I plug that in place of the x, right? So it's 2 times 1 squared minus 1. All right, so everywhere I have an x here, I put the number that's in the parentheses, the 1, and then I would go ahead and calculate that and figure out what it's equal to in order to calculate f of 1. All right, so that's evaluating a function. All right, so to do f of a plus h, right, which is that first part of my difference quotient, and like I said, sometimes the most difficult part for students to grasp, what I do is, just like what I did here, right, everywhere there's an x, I put a 1. Up here, everywhere there's an x, I'm putting a plus h. All right, so it's 2 parentheses a plus h squared minus parentheses a plus h. Just like down here, it was 2 parentheses 1 squared minus parentheses 1. All right, I did the same thing here, it's just I don't have a number here. I have this expression that includes 2 letters, but it's the same idea. Wherever the x is, I take whatever's in this parentheses, in which case is a plus h, I put that in place of every single x that I see in my function definition. Just like I put the 1 in place of the x's down here. All right, hopefully that makes sense, because like I said, when I've taught this stuff to people in the past, this is usually the part that gets people all hung up. They don't understand what to do. Sometimes people do, well, it's 2a squared minus a, and then I put that plus h at the end of everything. It's everywhere there's an x, you take that whole quantity, that parentheses a plus h, keep that stuff together, and everywhere there's an x, you put that a plus h in place of the x. Right? And if there's more than one x, like there is here, we put that a plus h in for every x that we see. All right, so hopefully that makes sense. And once we get that, now we just need to simplify this as much as we can. All right, so the first step to simplify, we have this a plus h squared, right? Following the order of operations, I have to do stuff with exponents before I can like multiply that 2 or distribute the 2 into the parentheses. I have to do the exponent first. All right, so another thing that people get hung up on. All right, let me put this down here. A plus h squared, that is not equal to a squared plus h squared. Right? I've made a bunch of videos so far, well, maybe not a bunch, but I've made a few videos so far on a couple of different topics, the rules of exponents and working with algebraic expressions, where we saw stuff like this. Right? So if you think that this should equal this, you should go back and look at the videos I did on the rules of exponents, or look at the ones I did on multiplying algebraic expressions to show that this is not the case. Right? When you have addition or subtraction inside that parentheses, you cannot just distribute the exponent. Right? What a plus h squared does equal is a plus h multiplied by another a plus h. That entire parentheses multiplied by itself again. And then to multiply this out, you have to use the FOIL method. Right? A times a equals a squared. A times h is ah. H times a is plus another ah. And then h times h is plus h squared. So we get a squared plus 2ah and then plus h squared. and then minus that a plus h up there. All right, so that's what we get from a plus h squared, right? It's not just a squared plus h squared. You actually have to multiply it out and FOIL it to get all this stuff. All right, so that's another part of these problems where sometimes students make that mistake of just trying to distribute the exponent when you cannot do that. All right, so watch out for that as well. Right, and now to simplify this a little more, if I distribute this 2 into this parentheses, if I distribute this negative here, I'm going to get 2a squared plus 4ah plus 2h squared, right? So multiplying that 2 times all the stuff inside the parentheses gives me this. And then when I distribute that negative, it's going to be minus a minus h. And then I'm just looking here to see if there's any like terms I could combine together, but there are not, right? I have an a squared and a to the first power. Those don't mix. An h squared and h to the first power. Remember, I can only combine those if they have the same variable with the same exponent. I have the 4ah here, but this has an a and an h. These are just an a and just an h, so those can't combine with the ah, and so there's nothing else I can do here. This is my f of a plus h, right? This is what's going to go into my formula up here for that f of a plus h. It's going to be 2a squared plus 4ah minus 2h squared minus a minus h, which is a mouthful. But that's what it is. All right. And like I said, a lot of times when you're doing these different quotient problems, that's the part that gives people the most trouble, is actually putting that a plus h there and understanding what to do with the a plus h, and then actually doing the algebraic stuff to simplify it when you really don't have that many numbers there. It's just a bunch of letters that you're working with. But remember, when you're working with the letters, you still have to follow the same rules of algebra, right? You still have to do the order of operations, the exponents before the multiplying. You still have to square something by multiplying it by itself. All those same rules apply. All right, so that's f of a plus h minus f of a. Oh, no, that's just f of a plus h, sorry. The next part of the difference quotient is minus f of a. All right, so f of a, I'm going to do basically the same thing I did up here, except this one's going to be a lot easier, right? Just like before when I had that 1 in the parentheses and everywhere there was an x, I put a 1. Well, f of a, I go back to my function definition, right? F of x equals to 2x squared minus x. Everywhere there's an x, I put the a. So f of a is going to be 2a squared minus a. Right, and here there's nothing to really simplify, there's nothing to multiply out, because it's just an a squared and a minus a, whereas here that a plus h squared, I actually have to square that and multiply it out. A squared is just a squared, there's nothing else I can really do with it. So this is my f of a. Right, this is what's going to go into my difference quotient up here for that f of a piece of it. All right, so we're ready now to put all this stuff together. I'm just looking at this board trying to figure out how exactly I'm going to do that. I'm going to have to erase a lot of this stuff here, but I need to keep our results so I can write them down. All right, so my difference quotient. Let me write up the actual formula for it. F of a plus h minus f of a all over h. All right, so that's going to equal f of a plus h is this whole big thing here. So 2a squared minus 4ah plus 2h squared. That's not even enough right here. I'm going to have to do this down below. So you know what? Let me try to write it here. It's going to be 2a squared minus 4ah plus 2h squared minus a minus h. All right, that's my f of a plus h. All right, so that's this part that I had here. Now I'm going to get rid of because we copied that down. And then minus f of a. So that is minus my f of a, which was 2a squared minus a. And then it's all of that stuff over h. All right, so that's what I end up with. And now it's a matter of simplifying that numerator and simplifying this stuff as much as possible. All right, so I'm going to have 2a squared minus 4ah plus 2h squared minus a minus h. All right, so that whole first part, I can just drop the parentheses from around that because there's nothing in front of the parentheses. All right, for the second part, though, I need to distribute that negative into that second parenthesis. So it's minus 2a squared plus a. Right? Another common mistake people sometimes make is forgetting to distribute that negative. And look what happens here. If you're doing everything correctly, everything that doesn't have an h in it should get canceled out. Right? The 2a squared, the minus 2a squared, the minus a, and the plus a. And what I'm left with is minus 4ah plus 2h squared minus h. Those all have a common factor of h. So I can factor out that h, which leaves me with minus 4a plus 2h minus 1 all over h, and then the h cancels out the h in the denominator, and I get my difference quotient of negative 4a plus 2h minus 1. And that's my difference quotient for this function.